Hey there, students. Mr. Rising here, and this is the Modeling Data Performance Assessment. In my worldview, this is probably some of the most important stuff you should actually be learning in mathematics, because it is the application of mathematics and you can really dive into the theory. I want to just give you a little background here about myself. I spent about 10 years in the computer and finance industry before coming up to Alaska, and I at one point was a financial engineer, and I looked at, I built mathematical models and managed weather-related financial risk. And so after getting exposed to that, I thought it was a really cool idea. I also spent some time doing financial contracts, like working for a period of time and taking off. And I ended up ski bumming. And so that's kind of what, that's not the one I want. That's what this photo is. This is a buddy of mine, beautiful snow. This is in British Columbia, in central British Columbia. But the point of that is actually really related to this class and your future and beyond. We do all these things, but the reality is, whether you go to college or you go to the workforce, the military, whatever, having the ability to analyze things, to look at things, to actually apply math and build models on real world situations is invaluable. In fact, it makes you a more valuable person. So my goal is to try to make this course more relevant and meaningful by showing you this idea. In this unit, we talked about correlation and scatter plots, and so that basically we're going to apply that. So the directions here are as follows. I'm going to make this a two-part video, and I'm going to stop after a certain point. The first part says, what is something that interests you? And I just shared with you things that interest me: weather, data analysis, skiing, all that kind of stuff. Then you're going to find a data set that relates to your interest. Then you're going to create a scatter plot with a spreadsheet, and I'm going to show you how to do that. And then the other part, 4 through 7, I'm going to break into a separate video. In my example here, I live in Seward. We have a ton of snow. Like right now, last night I had to put up plywood over my windows because the snow is already up to the windowsill. It's only January, and it's like the snow's going to lean against the windows, and I'm worried they're going to break the windows, because I know in February I don't want like a glacier coming through my living room. So I put up plywood. So my question, my interest is like what's going on with the snow level, the precipitation level? When you ask your question, I mean, whether you're interested in finance, in stocks, use the internet. You're going to have to find a data set. You're going to need at least 10 data points. If you're interested in politics, look at politics. If you're interested in fashion, if you're interested in food, find your sports, right? Find your interest. Center for Disease Control, COVID, public health. If you're interested in weather and climate, Center for Data, NOAA, those are great sources. Here in Alaska, there's AOS, AOS.org, and they've got this really cool website. It's like 511 on steroids. And it's called the Ocean Data Explorer. It has linked, I'm going to the real-time data, it has linked all these live weather stations and historical data sets from all over the state: ocean, land, snow, you name it. It's really cool. And I actually changed my filter here to precipitation, and I'm going to zoom into Seward. Here's Seward, and actually the colored dots mean there's active weather stations or data. So I clicked on this one. It says Grouse Creek Divide. That's our ski area. It's a little bit higher up. So I'm going to click on it. I'm going to move my picture out of the way. And basically, long story short, I downloaded the data set from all the precipitation. And so these things typically come in text files or Excel files. Let me just go like this. I'll blow it up a little bigger. Oh, here's air temperature. Here's precipitation. Oh, cool, precipitation. This one has a little dragger bar, so I'm like, all right, let's just go back in time. How far back can we go? I can go back and get data apparently to 1994. Bins meaning like, do you want it every month, every year, every season? I went to season, blah, blah, blah. And then I hit download. And it basically gave me a data set, and it opened in Excel, and it looked like this. Now, again, I'm really experienced with spreadsheets, and so I did a lot of monkeying, and I'm picking something a little harder than usual. But here's what I'm asking you to do. Once you get your data set, once you find it, all right, what you're going to need to do is create a Google Sheet and paste it into a Google Sheet. So let me start my instructions there. So I've put a lot on you. Ask a question, find something you're interested in, get a data set, and now I'm happy to work with you and help you do that. But let me give you some instructions on what to do once you get there. You're going to log into your school Gmail account, and then you can go to, up here, you can go to Sheets. You're going to create a new sheet, blank, right? Give it a title, pre-divide precipitation. Okay, done. Make sure you share it with me, so that way when you submit it, I can look at it. So I'm going to go share, and again, my user is george.scraba.rising. There I am. Boom. And again, you can make me an editor if you want me to be able to change it, or a commenter, I can make notes, or just a viewer. You might want to make me an editor so I can help you more if you need it. I'll send a little notification. And then I can paste my data in it. That's not very helpful. Let me go back and grab that one more time. Let me just copy everything. Little technical difficulty. There's my data. Hey, work, paste. Okay. So what I have here is I basically have from December 21st through March 20th of each year, and the mean precipitation that accumulated over that time, probably in snowfall. These are the winter parts. Now, if you're working with data on over time, there's some sort of year here, right? It's like 2000, 2001, et cetera. It's really helpful to, if you're trying to build models, is to just say year or time or something like that. And you can always say starting in time 0 or starting in time 1, something like that. So I'm going to go 1 and then 2, 1, 2, 3. If you highlight these and grab this little corner here, it's like, oh, you mean you wanted to fill in the rest of them like that? And the answer is you do. So what I want to do here is I want to make a scatter plot first of all. And so I'm going to highlight the 2 columns of data I want. And I'm going to go up here to insert, and I'm going to go to chart. And depending on your data, it might give you a trend line, it might give you it might look like this. But basically, if you go up to chart type, you can scroll down and you'll actually, let me get my picture out of the way. You'll see scatter plot down here a little ways, boom, and there's a scatter plot, which is part of your goal. Awesome. Number 1, make sure you have it labeled appropriately. You can see this is year. Mean is not super helpful. See if I can rename that, add label. It's like, I'll fix that. I'll fix that in a bit. But basically, mean what? What am I measuring? So that should be like precipitation in inches. Cool. And then under customize here, again, this actually gives you all the options, colors. Chart and axis title is really good. So this is like precipitation, precip versus year, precip in inches versus year. Give it a nice title, right? Scroll down some more. You'll notice here when I clicked on series, it also says trend line. And when it does trend line, you're really telling it what kind of regression you want to do. It's like build me a model, because what you're going to do is you're actually going to try to build a model that goes with this. And I'll include this in the next video because I don't want this to go too long. But remember, just like you have linear functions, there's exponential functions, and there's polynomial, logarithmic, powers, all these different kinds of sinusoidal, right? You can make all different kinds of models, and that's what computers are really good for. You may have to do this a couple times to find a model that works. If you're working with population data, things that are growing exponentially or decreasing exponentially, you're going to want an exponential model to go with it. All right, so I'm just going to call that good. You can see my trend line. And now in the next video here, I'm going to show you how to analyze this data, and we'll go from there.